tomography. Network tomography refers to study of vulnerabilities and security aspects for network monitoring in a complex system. So we are applying tomography in the network itself. So what we are going to do in the network, we monitor entire system of network where there is a any chance of vulnerabilities, where there is any chance of security issues which can occur, and we'll study this. All these things will be studied, and when we study, we use this tomography so that we can represent each and every object present in the network, its behavior by monitoring, and any differences observed using the three-dimensional figure. Three-dimensional, you can say, image, which will give you the kind of analysis, whether there is any kind of weakness, vulnerability, any kind of security breaches are happening. What kind of these networks will be there where we can apply the tomography, network tomography concepts? We can apply this in WSNs, wireless sensor networks, RFID networks, IoT networks. Even we can use tomography where some resources which are allocated in the network and which are used for specially ensuring the reliability and security of that network. So all these can come under the tomography. Everywhere we can apply this tomography, so we can observe, monitor, watch, you can say, entire networks. That can be a wireless sensor network, that can be RFID networks, that can be IoT networks, that can be some resources which are allocated for in the network, which are making that entire network reliable and secure. So we can watch them also. Then next is layered attack model. Layered attack model, as we are using web or internet, and then apart from it, even also we are using IoT. And when there is a network, we use some protocols like TCP/IP or something like that, so that we can communicate over the net, right, over the web-based, we can say. So there are these protocols are at different levels, right? If we consider TCP/IP, then TCP/IP itself have different layers which do separate functionality, right? Maybe application layer, transport layer, data layer, physical layer, network layer, like all these things, all these layers, and they do their specific tasks, specific jobs. And layered attacker model, here all these layers can be attacked, can be vulnerable. So there is possibility or possible attacks on these layers can happen. So we'll see that layer wise, what are the chances, what are the different things can happen. So we divide your, you can say, communication into different layers. We take here 6 layers, especially. First is physical, or you can say physical come data link layer. Second is data adaptation layer. Third is network. Fourth is transport. Fifth is application support. And sixth is applications or services. So there can be applications, there can be services provided, and there can be some support to these applications or services. There can be a transport layer, network layer, data adaptation layer, then physical come data link layer. So all these layers we think about when we uh, use IoT, or you can say web-based networks. And all these layers are not secure, or we can say there are chances of possible attacks on these layers. On these layers, it means the functionality what they do. On that, there are chances that some eavesdropping or attack can happen. So in first layer, we'll see. So in first layer, physical come data link layer, as I said, we have named these different layers and we have given the numbers to them, right? First, if I say layer one, it is a physical come data link layer. If I say layer four, it will be a transport layer. If I say layer number three, then it is network layer, like that. So on first layer, physical come data link layer, what are the possible attacks can happen? So there can be insecure in protocols, maybe DHCP or STP. There can be a LAN node attack using the MAC flooding, ARP poisoning, physical or service disruption or attacks on wireless networks. So this can happen in on layer number one. ARP, address resource protocol. So these are the possible attacks on layer one, physical come data link layer, insecure in protocols, especially we are mentioning DHCP, STP, LAN node, MAC, flooding, ARP poisoning, physical or service disruption, or attacks on wireless networks. On second layer, data adaptation. Here, unencrypted data store can happen. Tampering, we say. Sniffing, we say. So all this can happen on adaptation layer. So these are the vulnerabilities which we are mentioning on a specific layers. So these are the chances of vulnerability so that attackers can attack on this or using these kind of operations they can attack, they can make an entry inside the system which is secure, we are saying. On third layer, network layer, packet sniffing, as it is network, packet sniffing and DOS attacks can happen here, such as ping floods, ICMP attacks. This can happen on this network layer. Normally, what we do, we maybe you observed or not, or you have checked. If I want to see whether network is active or not, I can ping it, right? PING, ping. I can ping. So I can write ping and the IP address. So it will give me which packets are coming and their sizes, whether packets are incoming, outgoing, all this stuff. And by observing that, I can guess, I can guess that network is active, no network failure, and there are some packets which are received and some packets which are going on or sent over the network. So this can happen. And using these operations or this thing, the ping floods attack can happen, and which is on a specially network layer. ICMP attacks. Fourth layer is transport, and transport means traveling, or you can say when packets are actually sent over the network. And there will be some communication ports, vulnerable ports. So there are chances that when there is a transport happening of messages, you can say data, all these are sent over the packets, right? And they are sent through a particular, you can say, outgoing channel, and they are received through a incoming channel, and all the channels we say ports, right? For communication, almost there are more than 100 or 200 or 500 ports are available which we can use, and through using these ports we can communicate, we can send the data, and all these ports will have numbers, different numbers, and those are called as a port addresses. So this is like I am sending a letter, right, to my friend, and that letter is sent through a particular channel, right, on the network, through which that channel is through the letter is going on and received. So the attacker think that this is the possibility where we can stole that message. And on fourth layer, transport layer, the ports are vulnerable and those are find out and those are attacked. Right? So this is the possibility of attack on layer number 4. We have seen physical come data link, data adaptation, network, and transport. Next is fifth and sixth. So fifth and sixth, as we can see different layers, but they are almost same. Like there are applications and they require some support. So there is application support layer which is helping them. There are some services which require some additional support. So application support layer is helping them like this. So on these two layers, there are chances of attacks, vulnerabilities. So there can be vulnerabilities in application or service and which are exploited through attacks such as SQL injection. So we can use SQL injection so that we can explore the type of attacks which can happen in applications or services which are provided or application support on both. And here developer is fail to ensure that user input is validated against a defined schema. And that is the one reason where this SQL injection kind of a thing attacker can attack using this. So there are vulnerabilities in applications or you can say services. So these vulnerabilities are observed by attackers and they attack on this. Now developer here in applications and services, sometimes developer don't know what user input is giving, what kind of input is supposed to give, and no such kind of validation system is present. And there easily these attackers find out the vulnerability and they can enter or they can breach the codes, they can hamper the system, they can stole the data, they can use the stolen data to do other things. So this is the possibility of attack on layer number 6 and 5. 6 and 5 layers are applications, services, or application support. So this figure, you can take a screenshot or you can make it bigger. You can draw, just take 2 minutes pause so that you can just go through it. Those who are taken screenshot or drawn figure, they can just go through the figure, just read out at what layer or what are the possibility of attacks. The figure is layered attacker, excuse me, model and possible attacks in IoT or M2M. M2M, you can say machine to machine communication protocol. Right? Hope I am audible and screen is visible to you. Okay, we'll move on. We've seen the layers and possible attacks. So how to stop them? how to avoid this breaching of security, how to identify the attack, how to identify the attack and how to stop it. Main intention is how to avoid this, how to stop it. So we'll see now how to do it. So layer one attack solution. So layer one attack solution depends on the devices used. For example, as we see, data link layer we are saying, or physical come data link layer. So link layer provision of security we have to see, and based on that we can provide the solution. We can use different algorithms which are available for making this layer. You can say physical and link layer, or physical come link layer, data link layer. We can use different protocols, as I said. So there can be BTLE link level, AES, which is named as BTLE link level AES CCM 128. 128 indicates it is a bit key. Advanced encryption system, AES. So we can use this algorithm, authenticated encryption algorithm, which gives us the confidentiality and authentication. So we can authenticate the parties which are communicating, and we can provide the confidentiality. So the message will not be visible or gettable, readable at all. It will be a confidential between only those two parties and which are authenticated. So we can provide this using this algorithm the confidentiality and authentication in layer one. So it depends on the devices used and the link level provisioning of security we can maintain by using the encryption algorithm, which specially giving us the confidentiality and authentication. Also, we can provide link level link level security using this ASCCM 128 at Zigbee protocol also. So layer one is possible attacks are identified and we can stop them, and we can have these algorithms. We can have these algorithms to stop the attack, possibility of attack, and we can avoid, we can use algorithms which will ensure us the confidentiality and authentication. So this is the layer one attack solution. We'll move on for next level two. Layer two is, you see, layer two is data adaptation. Encrypted data store, tampering, sniffing, these are the possible attacks. We can use DSCP or STP, sorry, that is a spanning tree protocol. So we can have the arrangement programming in the network switches so that we can provide internal node attacks when we use DSCP or spanning tree protocols. So we do have this provision that whatever network switches we are using, we can have the programming. So we can make a strong programming in the network switches so that we can use these protocols and stop the node attacks. We do have additional controls also along with this programming. ARP inspection. So we can inspect some protocols which are providing some different functionality, like ARP, address resolution protocol. So we can inspect this protocol, how the addresses are resolved. And definitely we do have the confidentiality and authentication protocols at layer one. Even disabling unused ports. As I said, there are a number of ports available so that we can communicate by using these ports. We can send data and we can receive the data at these ports. Right? So we can disable which are not used. Sometimes ports are open. Ports are open means maybe you observed you're moving on and somewhere if your Wi-Fi is on, or you can search it. So if it shows number of, you can say, other spots, hotspots, right? Names, Wi-Fi is available, and there you can see on that there is a sign lock. Sometimes these locks are there, and sometimes some names are there without lock. Without lock indicates these are the open, you can say, Wi-Fi hotspots where you can log in and you can access that. Login means you can access it, you can join it, you can join that network, and if it is providing internet, you can use it freely. So this can happen as there are number of ports and some ports are open. So easily you can join those open ports and you can use for communication, or you can enter your programmed parts through those ports inside the system. So that is what we are saying, SQL injections like that. Virus is what? Virus is a different part which is not belongs to the system, but it can get entry, and once we click on it, it starts doing its operations. So disabling unused ports, inspecting address resolution protocols, enforcing effective security on VLANs, VLAN, virtual LANs, WLAN, or we can say wireless networks. So we can enforce effective security on VLANs so that we can prevent VLAN hopping, eavesdropping, hopping, attacking. All these are the types of attacks. Types of attacks are basically two, active and passive. Inside that, we can say that some you can say based on the definitions, those are named. Packet snooping, right? Hopping. So these are the different types. So in layer 2, we can have a solution on possible attacks, that we can use the higher programming, or you can say base programming, which is provided, which is used in network switches, so that we can provide the attacks when we use the protocols, STP, spanning tree protocol, DHCP. Even we do have additional controls. So we can observe the or inspect, monitor ARP protocol, address resolution protocol. We can disable the ports which are open, unused ports which are usable. Those will be definitely used with proper security. And which there are some ports which are not used, but maybe they are open. So we can stop them. We can disable them so that others cannot use, attackers cannot use those. And when there is a virtual LAN, so we can stop this virtual LAN hopping by using the effective security. So these are the possible solutions for layer 2 if attacks are happening, and we can stop them, we can prevent them. We'll move on for next layer. One more is there in layer 2, M2M authentication server, MAS it is known as. So provisions for MAS, so that we can provide a security by using this MAS, M2M authentication service server, machine to machine authentication server, which authenticates each and every machine present, each and every node present inside the network. Root key data store, devices authentication, data authentication. So these are the layer 2 attack solutions, possible layer 2 attack solutions. Next is layer 3. We can use a temper resistant router. We can use packet filtering, so that packet should not be catched, should not be, you can say, traced how they are traveling and all the stuff. We can have a better firewall systems for controlling all these routing messages. So firewall prevent, it will not allow unused or unwanted, unvalidated, sorry, you can say invalid packets to enter inside the network. So these firewalls will be there, which will prevent all these kind of things. So we can use layer 3 is network, right? Layer 3, layer 4 transport, layer 3 network, where packet sniffing and DOS attacks, ping floods we have seen, ICMP attacks can happen, and we can prevent them by using the temper resistant routers, strong routers, use of packet filtering, firewalls for controlling routing messages and packets, which are you can say used as maximum 3 and 4, layer 3 and 4 are using this, and there are the maximum chances again of attacks. We can stop them by using this, the special routers, packet filterings, firewalls. Right. Now we'll move on layer 4, port scanning method to identify the vulnerable port. So we have a algorithm, or we can have the separate mechanism, that is port scanning method. Do you know when we use JDBC or something like that, database connectivity, last time we have seen, we use the port number, some special ports for that, 3306, right? So this is the port which we use. And we can scan all these number of ports which are available. Scanning is used to identify weak ports, vulnerable ports, and we can stop, or we can close those ports, disable those ports, or provide better security. We can remove the vulnerability. Effective firewall configuring and opening of network ports and locking down ports only to those required. And this is the best solution in layer 4 transport. This is like if you want to access the port, just give your authentication. Yes, you are authenticated. You do have a time again. We can stay like locking down means we can have the specific rules for it. Either we can allocate a time, or we can allocate a key, so that by using key only that port is accessible. Even you have to show your authentication if you want to use that. As a process, suppose as a process, I want to communicate, JDBC, I meant to say. I want to communicate. I want to use this JDBC so that I can communicate. Then either I will allow it by time, I will have a special slot, else I will have a key. I will give my authentication. I will prove my authentication, and then I can use it, so that those will be available. So this is what we can do in layer 4. So there will be a port scanning method, which scan the ports and identify the vulnerable ports. We can have effective firewalls configured, so that whenever there are ports are used, either we can lock down them, or we can restrict the use. Sometime in examination you have observed, if you want to give the examination, you have to show your hall ticket. I can't. Then you are allowed to sit in the class and you can attempt the examination. Right? Such a way. In place of you, nobody can enter, right? So there will be hall ticket on which your authentication will be written, your name and all the stuff, how, which paper you are going to appear. If you are the field form for final year and you are coming for third year paper, it's not allowed. Again, there will be a photo, there will be a PRN number, there will be a proper signature, or some checking system will be there, right? So such a way we'll allow the resources, we allow the ports to use to process different processes, systems, or whatever, those who are communicating, when there will be some authentication process, there will be some you can say security. If some ports are vulnerable, where like nobody checking, we will find out which are those gates, which are those ports, and we'll close it, we'll stop it. So this is the possible solution for layer 4 attack. Again, DTL is between layer 5 and 6. DTL is datagram transport layer security. This is a long form. Datagram transport layer security between layer 5 and 4. The DTLS, three types of security services are available and which we can provide: integrity, authentication, and confidentiality. Even we can include SSL, simple authentication, and security layer, so that we can use this when we are using XMPP protocol and we can provide the security. So we can use DTLS or SSL and we can stop the attack types of attacks. This is regarding 4 and 5. 5 and 6 now. There are 5 and 6 possible types of attacks. The results of poor coding practices of application programmer allows this kind of thing. That's why we said we can use strong programming, so that if there are some lacunas, there are some vulnerabilities, there are some weaknesses, we can remove and we can have a coding practices, strong coding practices for the programmers. We can use HTTPS communication link, not only HTTP, which is again vulnerable. HTTPS is not vulnerable. So this kind of communication link for web applications or services which are used. So for layer 5 and 6 application, we can use strong programming. We can have coding practices for programmers, so that we can uh, we can increase the security, I can say, and we can use the HTTPS communication links, so that if we are providing some services on web applications, then we can use this HTTPS, which is again stronger, secure as compared to HTTP only. Hypertext Transfer Protocol. HTTPS, which is again Content Privacy Domain Header, allows use of digital signatures, encryptions, various encryption options, again, not only encryptions, various encryption algorithms they can allow. It allows digital signatures. So HTTPS, that's why it is a strong, because it is using digital signatures. Again, there is a cryptographic scheme is attached, assigned for this link. Specific algorithm is, the value assigned algorithm is used in HTTPS. Direction specification done for one-way or two-way security. We can also provide that wherever required one-way or two-way required two-way. So that is why direction specification is done in HTTPS. So HTTPS is more stronger, more secure as compared to your simple hypertext transfer protocol. So we can use that and we can stop the attacks which are happening on layer 5 or layer 6. Again, some Cisco suggested layer framework solutions are there. So they say 1 to 6 role-based security, layers 1 to 4 anti-tamper and detection-based security. Layer 1 to 6 data protection and confidentiality. Layer 1 to 6 IP protection. So Cisco is also suggested some layered framework solutions. They say that go for role-based security, anti-tamper, detection-based, data protection, confidentiality, IP protection. So all these protocols we can use so that we can provide the better security. So this is what we have learned in tomography related. So we want to identify vulnerabilities, ports, vulnerable networks, vulnerable layered attacks, and we can provide the possible solutions. So that's it for this lecture. Next time we'll go for next points. So this is regarding your fifth unit, which we have introduced, started with privacy, security, and vulnerability. Then we have seen use cases, misuse cases, and security tomography and layer attack model. So up to this, anybody have any doubt? Hope I am audible to each and everyone. Loud and clear. So anything from your side? Anybody have any doubt? Is just one question for all of you. Is ICS your security subject? Is this? This is subject. So this is going on for this sem. Yes. Am I audible? ICS हा सब्जेक्ट ह्या सेमला आहे का तुम्हाला? ICS.
No, sir.
Okay. Okay, many terms will be new to you. Actually, this would have been better if ICS is previously covered and then we are going for that. Because when there is a security, there are some terms which required. Definitely, you are going to get it. Maybe it is next sem. ICS is there. ICS will be there. So you can see the different protocols. Even you are going to do practical in that, and you can understand how these AES, DES algorithms are work, all the stuff like security, all the concepts of security, ciphertext, encryption algorithms, decryption algorithms, single key encryption, public key, private key, all these are the terms related to your security. When there is a subject in detail, you are going to get. Just for time being, for this unit only, we require the security and things, so we can have this introduction, I can say. In detail, yeah, you're going to learn. Still, if somewhere there are some problems, definitely I will explain the terms. That's why at start we have seen some terms like explanation, like what is encryption and all this stuff, message digest and all this stuff. So anybody have any doubt? So that's it from my side for this lecture. If you have any doubt, you can ask. Now it's time for attendance. In chat, type your roll numbers. But wait, type your roll numbers sequentially, starting with 1. So it will be better so that I can identify. So first 1 to 10, type your roll numbers. If you see your roll number is suppose my roll number is 5, and if there is a 4 roll number is typed, then I can go and I can type my roll number. Just take a small pause. If somebody is absent, next roll number is supposed to mark the attendance. So type your roll numbers sequentially, 1 to last 72. So starting with 1 to 10. If 1 to 10 are present, type your roll numbers in chat. Okay. 8, 9, 10, 11, 12, 13, 14, 13, 14, 15. Go on. 16, 17, 18, 19, 20. 19 is there, na Sonalkar? 20, 21, 22. 23. Okay. 67 श्याम मधूनच आलायस का तू? Yes, 27, 24. Again, don't break rules. 31, 32, 33, 34, 35, 36 आहेत का? 28. 33 to 40 कुणी आहे का? 41 to 45. Okay, 45 to 50. 45 to 50. 51 to 55. Okay, 55 to 60. 60 to 61 to 65. 66 to 70. 71, 72. 72 is there. Okay. So anybody remained? So type your roll numbers in the chat. Thank you very much. I have uploaded the videos. You can go to Moodle links or YouTube channel, and you can again repeatedly you can listen these. I'm recording these videos and I'm uploading it. Thank you. Stay safe. Take care. Good day. You can leave the meeting, no problem. Thank you.